Assalamualaikum and good day to Dr. Nur Azah, and every day our group will be presenting our group assignment, and its title is Rate of Reaction, Effect of Catalyst Toward Reaction Rate. These are our group members for this assignment. First, me, myself, NURUL HIDAYAH, RAISYAH SUFIA, ELAWATUN, Mohammad Zaimizan, and SITI QYASRINA ZULAIKHA.
Our population for this experiment is reaction with catalyst and without catalyst. Meanwhile, our sample is 7 reaction time reading with 7 temperature set for both population.
Okay, for the objective for this study, there are 3 objectives in total, which are: the first one is to estimate the mean difference for a reaction time between a reaction with catalyst and a reaction without catalyst. The second objective is to compare the variance of the reaction time between a reaction with catalyst and a reaction without catalyst. And the third objective is to identify the correlation between the temperature and reaction time in a reaction with a catalyst.
There are 3 significant of study, which are understanding reaction mechanism to gain insight into the reaction mechanism, quantifying the effect as to determine the differences of reaction, and industrial application to improve product yield.
For instrument, the sample data is using secondary data obtained from the experiment chemical kinetic factors that affect rate of reaction. It has seven readings with different temperatures to measure the reaction times for reaction with catalyst and without catalyst. Each of the temperature give a different reading of reaction times, like you can see in the table. So there are 3 statistical methods that has been used in this assignment. The first one is estimation of the mean for 2 population. Second method, hypothesis test about the population variance for 2 variants. And last method, person correlation coefficient.
Okay, now we continue with the data analysis using first method, which is estimation of the mean differences with 2 populations. This section discusses how to construct a confidence interval for difference between 2 population means when the samples are small and independent. Since both samples size are less than 30, we assume that the populations from which these samples are drawn are approximately normally distributed. Additionally, we do not know the population standard deviation, which is sigma 2 and sigma 1, but we assume that they are equal. To calculate the confidence interval for the difference between mean, first we need to find the value of mean for reaction time, for reaction with catalyst and reaction without catalyst, and we also need to find the value of variance of reaction with catalyst and reaction without catalyst. And we will get, for value mean 1, we will get 363.714. Mean 2, we will get 58.610. And variance 1 with 11685.880. And variance 2 with 781.557. So after that, we will compute the value of standard pool deviation by using the formula given. So after we substitute all the values inside of the formula, we will get the value of standard pool deviation for 2 samples is equals to 78.954. Next, we calculate the estimated standard deviation of mean 1 minus mean 2 using the formula given also, which result in 42.203. Then we determine the degrees of freedom using the formula as well, and we will get the value of 12. Then we need to find the critical value for 95% confidence interval using t-distribution table and alpha 0.025, which is 2.179. The confidence interval is then calculated using the formula giving us the value 214.944 to 398.864 seconds.
Thus, with 95% of confidence, we can state that the difference in the means of reaction time for reaction with and without the catalyst lies between 214.944 and 398.864 seconds, suggesting that the mean of reaction time without the catalyst is likely greater than the reaction with the catalyst.
Method 2 is about determination whether the variance of reaction time for reaction with catalyst and reaction without catalyst is different or not. This is the data that has been found in method 1. For reaction without catalyst, the mean is 363.714 seconds, the variance is 11685.686 seconds, and the degree of freedom is 6. For reaction with catalyst, the mean is 56.810 seconds, the variance is 718.550 seconds, and the degree of freedom is 6. There are 5 steps involved in this method. Step 1 is to state the hypothesis and identify the claim. Our null hypothesis is variance of reaction times are equal between reaction with catalyst and reaction without catalyst. Our alternative hypothesis is variance of reaction time are not equal between reaction with catalyst and reaction without catalyst. From the hypothesis, we claim that variance of reaction time of reaction with catalyst and reaction without catalyst is different, which is alternative hypothesis. Step 2 is to find the critical value. We use the significant level alpha 0.05 to find the critical value of F using the F distribution table. We know that to find the critical value on the F distribution table, we must do alpha over 2, which is we're going to use 0.025 table. This is two-tailed test because the symbol we use in hypothesis is equal and not equal, that refers to two-tailed test. Our degree of freedom of reaction with catalyst and reaction without catalyst are 6. Using the 0.025 F distribution table, the critical value of F is 5.82. Step 3 is to compute the test value. Since variance of reaction without catalyst is higher than variance reaction with catalyst, we said that variance of reaction without catalyst is our numerator and variance reaction with catalyst is our denominator. To find the test value of F, the formula is variance of reaction without catalyst divided variance reaction with catalyst. Then the test value of F is 14.952.
Step 4 is to make the decision. Since the test value of F is 40.952 and critical value of F is 5.82, where 40.952 is greater than 5.82. Therefore, the null hypothesis is rejected. Step 5 is to summarize the calculation. Hence, there is enough evidence to support the claim that the variance of the reaction with catalyst and without catalyst is different. The value of F test to sample for variance using data analysis in Microsoft Excel and our calculation manually and figure out it is exactly the same.
Method 3 is to identify the correlation between temperature and the reaction time for a reaction with catalyst. Step 1 is to computing the table with the value of temperatures x, reaction time y, x square and also y square. After we plot the data in a scatter plot, we can conclude that reaction time and temperature is relatively linear to each other. Step 2 is substitute the value from the table into the formula and solve R, and we get that the value is negative 0.993. And we can conclude that the correlation coefficient has a strong negative relationship between temperature and reaction time.
So for the next, the sample correlation coefficient R can be used as an estimator of the population correlation coefficient P using the hypothesis testing procedure. We decide to test the significance of the correlation coefficient at A equal to 0.05 using the t-test method. So the first step, state the hypothesis. HO P equal to 0, H1 P unequal to 0. Step 2, find the critical value. Since A equal to 0.05 and there are 5 degrees of freedom, the critical values obtained from the T distribution table are 2.576, 571. Step 3, compute the test value. Then we can calculate that T equal to negative 18.799. Step 4 and 5, make the decision and summarize the result. The test value T equal to negative 18.799 is lower than the critical value of T equal to 2.571. So we can accept the null hypothesis because the test value falls in the acceptance region. There is a significant relationship between temperature and the reaction time for a reaction with a catalyst. By using software as SPS statistic, these following results were obtained by this table.
To sum up the assignment that focus on introductory statistics to acceleration rate with and without a catalyst. That ACAP is objective by estimate the main different reaction time between reaction with and without a catalyst. It found that the reaction with a catalyst significantly reduced reaction time, indicating its role in accelerating reaction. Objective number 2 also is that comparing variants show catalyst reaction had lower variance, suggesting enhanced reliability. This study also examined the correlation between temperature and reaction time for reaction involve a catalyst, revealing a strong inverse correlation, demonstrating the synergetic effect of temperature and catalyst on reaction rate. Overall, the assignment successfully applied statistical method to optimize ration condition valuable for academic and industrial setting.